Let f is a function defined in this way. This function f is defined by ax minus b for x less than or equals to 1, and it is 3x for x between 1 and 2, and bx squared minus a for 2 less than or equals to x, or 2 less than or equals to x means x is greater than or equals to 2. Okay, so this function is given. So find numbers a and b such that f is continuous on real number. A function on real number continuous እንዲሆን a እና b ምን መሆን አለባቸው ነው ጥያቄው። We use the definition of continuity to find the value of a and b. So this function will be continuous on real number if it is continuous at 1 and 2. So the first case, we need to calculate the limit of f of x as x approaches to 1 from the left must be the same as the limit of f of x as x approaches to 1 from the right. 1 from the left means for x less than or equals to 1. So for x less than or equals to 1, we use ax minus b. So the limit of ax minus b as x approaches to 1 from the left is the same as the limit of 1 from the right means we use 3x. So 3x as x approaches to 1 from the right. Substitute 1 in ax minus b. So this means a times 1 minus b is equals to 3 times 1, which is 3. Okay, we have one equation here. We have one equation with two unknowns. Okay, the other thing, the function should be continuous at 2 also. So the limit of f of x as x approaches to 2 from the left must be the same as the limit of f of x as x approaches to 2 from the right. Now you have to know which functions to be taken from the right of 2 and from the left of 2. So from the left of 2 we use 3x. So the limit of 3x as x approaches to 2 from the left must be the same as the limit of bx squared minus a. We take bx squared minus a for x approaching 2 from the right. So we can substitute the limit here. We can substitute the value of x. So it becomes 6 is equals to x squared means 2 square, which is 4b minus a. Okay, we have another equation. So here we have two equations. The first one is this one, and the second one is this one. So you can use substitution or elimination, whatever method you like. So we take these two equations, a minus b is equals to 3, and 4b minus a is 6. So you can directly add it, a minus b. This a with minus a is 0. 4b minus b is 3b. 3b is equals to 3 plus 6 is 9. So dividing both sides by 3, the value of b becomes 3. Okay, so 9 over 3 is 3. So if b is 3, we can substitute the value of b here in the first equation or in the second. So a minus b is 3. Already b is obtained as 3. So a will be 3 plus 3, which is 6. Therefore, the value of a becomes 6 and the value of b is 3. So for this a and b value, the function will be continuous on real number. That means for other values of a and b, this function will not be continuous on real number. Find the value of k. Here, find the value of k so that f of x, which is defined by cos x minus 1 over sine 2x. This part is defined for x different from 0, and the function becomes k whenever x is 0. Okay, the question is find the value of k in which this function becomes continuous at 0. ይሄ function at 0 continuous የሚሆነው የk ዋጋ ምን ቢሆን ነው ጥያቄው። Okay, we will determine such values of k in which f becomes continuous at 0. So we use the definition of continuity to find the value of k. So by definition of continuity, okay, by definition of continuity, f is continuous. F is continuous at x is equals to 0 if this condition is satisfied. If the limit of the function as x approaches to 0 is the same as f of 0. Limit እና functional value the same መሆን አለበት. So we apply this definition to find the value of k. ይሄንን apply እናደርጋለን, then የkን ዋጋ እናገኛለን ማለት ነው. So the limit of f of x means the limit of cos x minus 1 over sine 2x as x approaches to 0 must be the same as f of 0, but f of 0 whenever x is 0 the function becomes k. f of 0 x in 0 ስናደርግ functionation k ይሆናል ተብለናል. So we evaluate this thing. ይሄ ምንድነው የሚሆነው ማለት ነው? This becomes the limit of cos x minus 1 over sine 2x as x approaches to 0 must be k ማለት ነው. Okay, እንግዲህ if you directly substitute x is equals to 0, cos 0 is 1 minus 1 is 0, sine of 0 is 0, which becomes 0 over 0. In this case we use a L'Hopital rule. Okay, so ሌላ ቴክኒክ ከመጠቀም ቶሎ መልሱ ጋር ለመድረስ we prefer to use a L'Hopital rule. So this is the limit of cos x minus 1 derivative over sine 2x derivative as x approaches to 0 is equals to k. So this is the same as the limit of cos x derivative means minus sine x minus 1 derivative is 0 over sine 2x derivative is 2 times cos 2x as x approaches to 0 is equals to k. Now you can directly substitute 0, so it becomes sine 0 is 0, 0 minus 0 and 0 are the same, 0 over 2 becomes k. So the value of k, you can crisscross it, 2k is equals to 0, which means k is equals to 0. Okay, therefore k is equals to 0, k is equals to 0 will be the answer, meaning that this function, the given function f is continuous at 0 whenever k is 0. Number 12, it says determine for which of the following functions we can define f of a so as to make f continuous at a. Okay, in this question number 12 there are 3 things, 3 functions አሉን። እያንዳንዱን function ለብቻ separately እናያለን. Now the a part, in a part we have f of x is equals to tan 3x over 2x squared minus 5x. Okay, this is the function. So the a value is a is equals to 0. Normally the function at 0, f at a means f at a for this case is f at 0. If you substitute 0 in place of x, f at 0 means tan of 3 times 0, which is 0, over 2 times 0 square minus 5 times 0, which is tan 0 is 0, and all this thing is 0. 0 over 0 is undefined. So this function, the function in A, cannot be continuous at A. Okay, it can't be continuous at A is equals to 0. Actually, we can have also other values of A value in which this function fails to be continuous. For example, we can't make 2x squared minus 5x 0. Okay, this should be different from 0. This means 2x, this means x into 2x minus 5 should be different from 0, which implies x should be different from 0, and x should be different from 5 over 2. Okay, not only at a is equals to 0, not only at a is equals to 0, this function is not continuous at 5 over 2 also. So a cannot be 0, a cannot be 5 over 2. In fact, we can have also other values of a in which f becomes discontinuous. For example, if we take f of x is tan 3x over 2x squared minus 5x. Obviously, we can observe that x cannot be 0, x cannot be 5 over 2. But tan 3x means sine 3x over cos 3x. Okay, in place of tan 3x, you can substitute this one over 2x squared minus 5x. Now, this tan will be undefined whenever cos is 0. Okay, whenever cos is 0, tan will be undefined. So we need to protect cos 3x to be different from 0. Okay, cos 3x should not be 0. That means 3x cannot be an odd integral multiple of pi over 2, because at an odd integral multiple of pi over 2, cos becomes 0. So 3x cannot be this number. That means x cannot be 2n minus 1 times pi over 6, where this n is an element of integer. Therefore, this function f, the given function in A, cannot be continuous at 0, at 5 over 2, at any x values, which is odd integral multiple of pi over 6 here. Okay, so these are the restriction. Therefore, we can make f continuous at any other values of x different from these numbers. Therefore, f is continuous at any real number except 0, 5 over 2, and odd integral multiple of pi over 6. So these are the restriction for f to be continuous. Okay, here x, I have to make it different from 0. So make it in this way. X should be different from 0, 5 over 2, and odd integral multiple of pi over 2. In B part, we will do the same thing. We will determine in B part, let's take the function f of x is x squared minus 1 over absolute value of x minus 1. Okay, obviously this function, the function at a means f at 1. If you directly substitute 1 in place of x, it becomes 1 square minus 1 over absolute value of 1 minus 1, which is 0 over 0. So f of 1 is not defined. F of 1 is not defined. So f will not be continuous at 1 because f of 1 is not defined. So let us see the value of a in which f becomes continuous. Now f of x is x squared minus 1 over absolute value of x minus 1. So this means the function will be x squared minus 1 over x minus 1, which is the same as x plus 1 for x greater than 1. The function doesn't exist for x is equals to 1, and it becomes x squared minus 1 over the negative of x minus 1, which is the negative of x plus 1 for x less than 1. Okay, we can explicitly write this function into these spaces. Now we can observe each of them separately. It becomes x plus 1 for x greater than 1, and it becomes the negative of x plus 1 for x less than 1. So each of these things are continuous because every linear function is continuous. Therefore we can write like this: f is continuous at any a value greater than 1. For any a value greater than 1, this function is continuous, and for any a value which is less than 1, it's continuous. So shortly you can also say that f is continuous in the interval minus infinity to 1 or 1 up to infinity. So these are all the possible values of a. So these are the possibilities of intervals of continuity. So any a value in this interval can make this function defined and continuous. Now let's see the C part. Okay, in C part, the function f is defined into two different pieces. The first piece is x squared plus 1. This works for x less than minus 1, and it becomes x for x greater than minus 1. Okay, so there is no way for this function to be defined at minus 1. Okay, so this function is defined for x less than minus 1 or for x greater than minus 1. So this implies there is no way or no values for f at minus 1. This is not defined. Okay, it's not defined. Therefore the function, so f is not continuous at minus 1, at a is equals to minus 1. That means for any other values of a, the function becomes continuous.